Another thing that's important is how much work is done by an external field during the rotation of the dipole from some initial orientation angle, say theta 0, to some final angle theta. So we define work as dW. Anyone remember how we defined work for torque? If not, we defined it as this from intro 1, also from Newtonian, or dot product, getting rid of the dot product, theta 0 to theta t d theta, cosine of the angle between them. And what's the maximum theta that we could have? 180. That implies cosine theta is -1, which results in minus theta 0 to theta d theta. And if you stare at this long enough, you'll realize that this minus sign means that theta and angle are opposite to each other. Torque tends to decrease theta. That's intro 1. Now, what happens for our case? Work equals minus d theta from theta 0 to theta. My value of torque is P cross E, or from here, let's call this equation B. May I replace this from equation B as minus theta 0 to theta. What is it? PE sine theta d theta, right? PE sine theta, yep. Or PE negative integration sine theta d theta. What's the integration of sine theta? Negative cosine. So that means I can rewrite this as PE cosine theta minus cosine theta 0. Or if I distribute it, may I write this as that? Oh, here, let me point that out, that integration of sine theta d theta is minus cosine theta. That's where the minus sign went. So this equation tells me something. This equation tells me work done by the external force produces the E field that is equal to the negative of the change in potential energy of the field plus the dipole. In other words, I can write W as minus u of theta plus u of theta 0. Or very simply, the same equation that we have been talking about forever and a day. Right? Work equals negative potential. So this gives us another definition of U. So potential energy is defined as U minus PE cosine theta, or in other words, minus P dot E. When will potential energy be minimum? When P and E are parallel. What does that mean? That means if the dipole is shaped like this, will it experience any torque? No, right? Because the angle between the D and the E are exactly the same. It will not experience any torque. Sine of 0 is 0. Got it? So in order for it to have a torque, yes, Nick?
So if it was starting straight up and then it's kept going, it would, when it got here, it would just stop? Or
No, because inertia will cause it to go forward.
You keep going, okay.
Right? So that is a great question. So if it starts here, you would expect that once it gets here, then it'll stop. But inertia causes it to go forward, right? It doesn't immediately stop. If it starts at this, what will it do? It will not go torque. That's a great question.